So what we're looking at is a sample that I pulled from the soil mix that was put into the raised bed at the Riceland Garden. And at the moment, I'm just trying to get everything focused. This is under 40x magnification, so a 4x objective, and then there's 10x built into the microscope. It's an Omax trinocular. I'm using an Omax 10 megapixel camera connected to the computer, running Toupeview. Toupeview is the software, and then I'm editing it in Wondershare Filmora. Now this sample, it's a brand new test tube that has not been used. It's a graduated 1 through 10. I've got 9 parts distilled water, 1 part of the soil mix, lightly agitated, let it set for about 30 seconds. Then I took a clean first use pipette and drew up some of the solution, expressed it out, drew it up, expressed it out about 3 times. And then on the 4th one, I took and put a single drop on a new slide with a new cover slip. It's been a while since I've done this, but at 40x, which is my lowest power objective, I'm just scanning through and looking for anything large, anything that seems to be moving and alive and large. So we've got bacteria, single cell bacteria at the very lowest level of the tropic soil food web. And then up from that, you get your amoebas, possibly some rotifers or some ciliates or something of that nature that eat the bacteria. There's also, bacterial feeding nematodes, which would be pretty big in this. So at this point, I'm really looking for that 2nd and 3rd level tropic for life that would be visible at 40x. And would be moving around, traversing, the screen seemingly with purpose and some speed. It would really stand out. And that's really what I'm scanning for, is just anything that's big and moving that I can see, and then I can go down a little bit closer if I want to try to identify. And for the most part, I'm not seeing anything. I'm seeing some organic material. Now, this stuff has been ground up and dumped on the ground. I don't know how long it was there, and then maybe a skid steer used to pick it up and load it in the back of a pickup, and then we took shovels and rakes, pulled that out. So it's been mixed and mauled and ground, so it's very loose, very aerated. Obviously is not anaerobic, but so any fungal fragments, any fungi that's going to be in it, it's going to be all broken to bits because of all that agitation. But I'm just not seeing anything. So now I am changing from 40x down to my 10x objective, which gives me 100x total power. Adjusting my focus, adjusting my light again. Been a while since I've had the microscope out. So now we're at 100x total magnification. And again, we should be seeing, if there is anything, those amoebas, those, flagellates, those rotifers, things, definitely rotifers as big as they are. Nematodes would look huge right here. Anything bigger than a bacteria moving around within the fluid, trying to find something to eat. And I'm not seeing it. I'm not seeing hardly anything move. Now, we can't necessarily see single cell bacteria just yet. But again, I'm just not seeing anything moving. You see little bits of maybe root fragments, organic material, maybe something, pieces of minerals. Almost looks like sand at this level, but a lot smaller than a grain of sand. There may be some fungal fragments in there, but I can't tell at this level. Nothing really big. So the only surprising thing would be if this was actual soil as opposed to, a soilless mix that's been pulverized and jumbled up a lot. I'm just not seeing anything alive and moving. And there's lots of other videos on YouTube you could look for to kind of see what, just look up soil microscopy. So now we're going to 400. So it's a 40x objective times 10, so 400 total. And that's as high as I can go on this particular microscope without having to get the oil out. And I'm really not in the mood to start getting the oil out for my 100x, which would give me 1,000 power. I do have another microscope coming that I think it has a 60x built, comes with it. So I don't have to use oil for that. I may consider getting a 100x dry objective for one or the other microscopes if need be. But again, I'm just having to adjust the focus, adjust the light and the aperture to try to get it illuminated where we can see things. I'm very, very out of practice and was never that great to start with. So now we're getting there. And when it clears up just a little bit, you should start seeing some individual dots that are either kind of clear or white or black that are just kind of vibrating. And those are going to be bacteria. So at 400, we can start seeing the bacteria. Again, playing with the light a little bit. And while it's good that we are seeing some life in there, some bacteria, the bad thing is there's nothing bigger eating them. And that means the soil food web doesn't exist. There's a significant amount of nitrogen that is going to be being tied up in all those bacteria. You have a lot more nitrogen compared to carbon than most of the other levels. So when you go up a tropic level and something eating bacteria, then that higher tropic level animal like an amoeba doesn't need as much nitrogen. So just like we do, we eat and then we excrete, either defecate or urinate. And in our case, as a mammal, our urine is very high in nitrogen. Well, the amoebas and other ones that eat bacteria are the same way. They need less nitrogen than they eat because they're looking for the carbon. So they excrete that excess nitrogen, which is now in a plant available water soluble form. So if there's nothing eating those nitrogen, then that nitrogen is tied up. It's not being released back to the fluid for possible absorption by the plants. Likewise, they're eating carbon, and because they are a living organism, living animal, they respirate. So part of that carbon that they're eating, they are essentially exhaling into the air. So carbon in the soil that makes up your soil organic matter is being lost. And this is how one of the ways where a heavily bacterially dominated soil loses organic material, loses carbon. And when we till or disc, we aerate the soil, we throw it really, really heavily into bacterially dominant, which does give a flash or flush of nutrients for the plants, but it also loses a lot of that carbon. So it's good to see life there. I don't know what the chemical analysis of this is. I'm sure it's fertile. It's probably because Dan's used it and had good results with it. But from a soil health and a soil food web standpoint, I'm seeing bacteria and nothing else. So the hope is that eventually we will have a lot more tropic levels of life